interactive online training on piping and instrumentation diagram. Module 1. Introduction. Following topics to be discussed in this module. 1. Content. 2. Course objective. 3. Intended audience. 4. Codes and standards. 5. Quiz. 6. Course director. Module 1. Introduction. Module 2. Preliminary engineering drawings. Module 3. Symbology, piping and valves. Module 4. Symbology instrumentation. Module 5. Symbology controls. Module 6. Symbology equipment. Module 7. Equipment identification and valve tagging. Module 8. Line numbering. Module 9. Instrument legend. Module 10. Case study parts 1, 2 and 3. This virtual online training on piping and instrumentation diagram has been developed by using interactive screenshots technique. This is an advanced and unique approach to train individuals on their own, without any instructor help. Experienced professionals and engineers could benefit to enhance their ongoing learning and refreshing their knowledge in industry. Engineering organizations could emphasize and encourage their employees to take this training for their better understanding and application on projects when come across engineering drawing interpretation. The most adaptable part of the course is that it can be taken anywhere, whenever, and wherever upon the availability of computer and internet. This interactive training has been divided into 10 modules, of which Module 1 provides brief introduction on intended course audience and international codes and standards. At the end of each module, a short quiz has also been included. The primary intention of this course is to provide training to technicians, technologists, and engineers in mining, chemical, oil, and gas processing industries responsible for small and large projects. The course introduces the process for using various drawing symbols and terminologies commonly practiced in the chemical and process industry. By enhancing their knowledge on how the P&Id is developed, created, modified, interpreted, and applied for when an engineering process advances. Engineers involved in basic, front-end and design engineering phases of the project, staff responsible for site operations and maintenance could also benefit from the content of this course. In addition to the specialized categories of personnel mentioned above, other employees, managers, and officers of the organizations could equally benefit from this course. The training would prove ideal for technicians, technologists, fresh engineering graduates, engineers in training, and professionals in career transition or seeking skill development. Significant effort has been made to provide as much detail, information, and explanation as possible. Pictures, sketches, and symbols have been employed wherever possible for easier understanding and grasp of the subject or article under review. It is presumed for the course participants with little or vast experience to have essential knowledge and understanding of the respective industry norms. Oil and gas, mining and chemical processing industries apply codes and standards published by internationally recognized organizations in order to execute design and engineering functions. Below is the introduction and some titles that are commonly applicable. ANSI. The American National Standards Institute, pronounced as ANSI, is a private non-profit organization that coordinates U.S. standards with international standards so that American products can be used worldwide. For example, standards ensure that a flange class 150 NBS to SA105 and is available anywhere around the globe. ASME. The American Society of Mechanical Engineers, founded as an engineering society focused on mechanical engineering in North America. Various codes and standards that have applications in the industry have been issued under ASME. Some commonly used standards and codes by ASME are ASME Section 2 Materials, ASME Section 5 Non-Destructive Examination, ASME Section 8 Rules for Construction of Pressure Vessels, ASME Section 9 Welding and Brazing Qualifications, ASME B31.1 Power Plant Piping, ASME B31.3 Process Piping, ASTM International. ASTM International, known until 2001 as the American Society for Testing of Materials, ASTM, is an international standards organization that develops and publishes technical standards for a wide range of materials, products, systems, and services. API. American Petroleum Institute, as the name implies, regulates the engineering practice in petroleum industry. Some commonly used standards and codes by API are API Standard 510, Pressure Vessel Inspection Code. API Standard 650, Welded Tanks for Oil Storage. API Standard 1104, Welding of Pipelines and Related Facilities. CSA Group. CSA, the Canadian Standards Association, develops and publishes standards in print and electronic form, and provides training and advisory services. Commonly used standards by CSA are CSA standards at 662 to 11, Oil and Gas Pipeline Systems. CSA standards at 463, Guideline on Maintenance of Electrical Systems. ISA. The International Society of Automation is a technical society for engineers, technicians, business people, educators and students who work, study, or are interested in industrial automation and pursuits related to it, such as instrumentation. ISA publishes ANSI ISA S5.1, Instrumentation Symbols and Identification. Other than the above-mentioned codes and standards, some other international standards, including British and European, are applicable in the respective countries or continents. They are briefly explained below. BSI. BS. British standards are the standards produced by BSI Group, which is formally designated as the National Standards Body, NSB, for the UK. The kite mark logo can be used to indicate certification by BSI. It is mainly applicable to safety and quality management standards. Following the move on harmonization of the standard in Europe, some British standards are gradually superseded or replaced by the relevant European standards, EN. DIN. DIN, the German Institute for Standardization, is an organization that develops and publishes standards on a wide variety of topics. Headquartered in Berlin, Germany, DIN is Germany's national standards organization, serving as its representative in the European CEN and the international ISO and IEC. DIN standards are synchronized with the rest of the world. CEN. CEN, the European Committee for Standardization, is an association that brings together the national standardization bodies of 33 European countries. CEN is one of 3 European standardization organizations together with European Committee for Electrotechnical Standardization, (CENELEC), and the European Telecommunications Standards Institute, (ETSI). CEN contributes to the objectives of the European Union and European Economic Area with technical standards, (EN standards). The CE mark is a declaration by the manufacturer that a product complies with the respective EU directive and hence the harmonized standards referenced by the directives. GOST. GOST refers to a set of technical standards maintained by the Euro-Asian Council for Standardization, Metrology, and Certification, (EASC), a regional standards organization operating under the auspices of the Commonwealth of Independent States, (CIS). The abbreviation GOST, Russian, SUST, English, stands for the State Union Standard. All sorts of regulated standards are included, with examples ranging from charting rules for design documentation to recipes and nutritional facts of Soviet-era brand names. Can you answer the questions below? 1. What does ANSI stand for? The American National Standards Institute. To what is the ASME code for rules for construction of pressure vessels? ASME Section 8. What is API Standard 650? Design Standard 4. Welded tanks for oil storage. For what is Germany's National Standards Organization? DIN. 5. What is Russia's State Union Standard? GOST. And this is the end of Module 1. In the next module, preliminary engineering drawings shall be covered. Lastly, a few words about the course director, Mr. Rabasali, PM, MS, Mechanical Engineering, Michigan, USA. In the span of over 17 years engineering experience, he spent several years working with EPCM firms on projects for various domestic and international clients. This course is part 1 of the series on interactive online training courses in engineering. For more information, visit www.mec-esi.com